Hello everyone, this is Vishal Shankar Srivastava, working as assistant professor in the Department of the Mechanical Engineering of GL Bajaj Institute of Engineering and Technology. Today we are going to discuss about magnetohydrodynamic energy. In this topic we include introductions, principle, working, advantage, disadvantage, application, references. Next slides. We'll start from introduction. Basically, magnetohydrodynamic is a process in which we produce electricity, electrical energy, with the help of ionized gas and magnetic field. As the name concerns, magneto and hydrodynamic. As you see, magneto and hydrodynamic means ki there is a role of a fluid and magnet. So in other word we can say magnetohydrodynamic power generation is a process in which magnetic electric power by means of the interaction of a moving fluid, usually you can say an ionized gas or plasma, and magnetic field, means कि आयोनाइज गैस को जब हम जो हाईली आयोनाइज गैस को जब हम किसी मैग्नेटिक फील्ड से पास कराते हैं, उनके बीच में जो इंट्रैक्शन होता है देयर इज़ अ इलेक्ट्रिकल फील्ड क्रिएट होता है, वो पोटेंशियल डिफरेंस के लिए रिस्पॉन्सिबल होता है और वहाँ पे इलेक्ट्रॉन्स का फ्लो स्टार्ट होता है और इलेक्ट्रॉन्स के फ्लो को हम करंट का जनरेशन कहते हैं. वर्किंग प्रिंसिपल ऑफ द मैग्नेटोहाइड्रोडायनामिक प्रिंसिपल. In this figure we saw there is a two electrode this is a upper electrode and this is a lower electrode, and the area of the electrode is A, capital A, we assume, whose area is A in the theory, and distance between this electrode is a D, and you show the velocity of ionized gas. V is a show magnetic flux magnitude, and capital V is a show potential difference. So when ionized gas passing from between these two electrodes at a speed u, and we already generated there magnetic flux B, so when gas interact with the magnetic flux, then there is a electric field generators, and that electric field create a potential difference, and potential difference create from when charges move from positive to negative, so there is a create a potential difference, and that potential create is responsible for the flow of electrons. This arrow show flow of electrons. This principle works on the basis of the Faraday's law. This principle is work on the basis. This is another diagram. By the help of this we clear how does it work. You show north and south pole, electric pole, there is a theta electrode, between these ionized gases passes from here, and when this ionized gas passing from here, so ionized gas energy is converted here into इलेक्ट्रिक फील्ड. बेसिकली यहाँ पे जो है जो गैस है हाईली टेम्परेचर पे आयनाइज्ड हो रही है, तो उसका टेम्परेचर बहुत ज़्यादा है, उस टेम्परेचर से ही हम हीट एक्सट्रैक्ट करके ही उसको हम इलेक्ट्रिसिटी से में कन्वर्ट करते हैं. सो इट इज़ ऑल्सो कॉल्ड एज अ हीट इंजन. MHD जनरेटर एक्ट एज अ हीट इंजन, इसलिए इसको हीट इंजन भी हम कहते हैं. इट्स एफिशिएंसी इज़ अबाउट 50 to 60% मैक्सिमम, इससे ज़्यादा नहीं हो सकता. जनरली इट्स वेरी फ्रॉम 25 to 35%. And the maximum power generated by the per unit volume is sigma u square b square by 4, where sigma is a thermal conductivities of the gas, u is the velocity of the gas, and b is a magnetic flux. There are two type working principle. One is a open cycle magnetohydrodynamic system, and other is a closed magnetohydrodynamic system. In open system, working fluid is once used, while in closed system we use working fluid twist, you can say circulate regularly. In this diagram we saw there is a combustor, nozzle, MHD duct, air preheater, inverter, boiler, seed recover, pump, condenser, steam turbine, stack, etc. This is a block diagram of an open cycle MHD generator. In this, oil or gasified coal is used as a fuel. Fuel is burned and combustor, which combustor, and the air is passing ionized gas, which is heated from combustor and sheeted with the help of cesium or potassium. Actually, seeded is a process by which we increase the ionization temperature. Cesium or potassium work as a chemical element which increase the ionization capability. So hot gases, ionized gases passing from the nozzle. Nozzle will help to accelerate the speed of the gases, which passes from MHD duct. This is a duct is just like a previous diagram where we saw that there is a two electrode, upper electrode and lower electrode. Between these two electrode, gases passes, and the process is same to produce electricity. मीन्स कम्बस्टर से जब आप हॉट गैस को यहाँ से टेम्परेचर हाई करके पास करोगे, यहाँ पे टेम्परेचर जो होती है अप टू 2500 केल्विन तक हो जाता है. देन सीडेट करके हम यहाँ से नोज़ल से पास करेंगे. नोज़ल जो होती है उसकी स्पीड को बढ़ा देता है, यू जो हम होता है यू को इंक्रीज़ कर देगा. फिर वो पास होगा हमारे MHD डक्स, मैग्नेटोहाइड्रोडायनामिक डक्स. मीन्स की एक कन्वर्जन डाइवर्जन टाइप का डक होता है जिसमें वो इलेक्ट्रोड्स का सारा अरेंजमेंट होता है. दो इलेक्ट्रोड्स का सारा अरेंजमेंट होता है जहाँ से वो पास करता है, और पास करने के बाद वही सारी इलेक्ट्रिकल प्रोसेस होती है जहाँ से इलेक्ट्रिक फील्ड क्रिएट होगा, फिर पोटेंशियल डिफरेंस जनरेट होगा, और वहाँ से हमारा इलेक्ट्रॉन का फ्लो होगा और करंट प्रोड्यूस होगा. उस करंट यहाँ पे एक बात नोट कर लीजिएगा, करंट यहाँ पे जो भी प्रोड्यूस होगा सिर्फ और सिर्फ डीसी सप्लाई होती है, न कि एसी. उस डीसी को हम फर्दर क्या करते हैं, इन्वर्टर की हेल्प से एसी सप्लाई में करते हैं और उसको हम यूज़फुली अपना यूज़ करते हैं. नेक्स्ट हम इसमें जो आप अदर डायग्राम शो कर रहा है, एयर प्रीहीटर, बॉयलर, सीड रिकवर. दैट मीन्स कि आफ्टर हीट एक्सट्रैक्टिंग फ्रॉम द आयनाइज्ड गैस, द टेम्परेचर ऑफ आयनाइज्ड गैस reduce to till 1900 Kelvin. So 1900 Kelvin पे इसके it's not so efficient. That means कि not working properly. So we cannot reuse. So that is passed through air preheater. Air preheater he is a work as a combustor. कोल को हम जो प्री हीट करते हैं यहाँ से ताकि वो बर्निंग में easily help करे. So we utilize that 1900 Kelvin gases as a preheater. After the remaining gases used as a boiler, steam converted into steam and run the boiler. Boiler can operate the turbine and utilize into some other power resources. And after steam turbine, we can convert the remaining gases into condenser and convert into water and use further, utilize further next whatever we want. Next process is closed cycle. In closed MHD cycle, working fluid continuously circulated from there by several methods. In previous we saw in open system we shall discuss that an air preheater, steam turbine, and there is a you can show ST1, ST2, that is a stack 1, stack 2, and there is a condenser. So in closed system working fluid continuously circulated and the helium and argon is used as a working fluid. This cycle is closed MHD cycle is work on Brayton cycle. Again I am repeating, this cycle is work on principle of Brayton cycle. So here एयर पार्ट्स आर क्लोज MHD साइकिल में पार्ट्स जो हैं एयर प्योरीफायर, एयर प्रीहीटर, कंबस्टर, हीट एक्सचेंजर, देन सीड यहाँ हो रहा है, then it goes to the gas MHD generator. After that the process is working principle process is same. Then DC supply we produce DC supply and convert into AC supply. Then remaining steam is supplied to the ST1, ST2, and compressor and other process we utilize. In this, argon and helium is used as a gas carriers, and when we burn the gas, burn the oil or gasified coal and produce high temperature for ionizing the gas. So that heat is came from combustion heat exchanger and provide to the air preheater. Just show this air preheater, and fresh air is consumed and raise their temperature up to ionization temperature, and that ionization temperature, from that ionization temperature is goes to the hot shedded methods. शेडिंग मेथड मीन्स कि ऑर्गन या हीलियम से हम इसको शेडेड कराएंगे ताकि इसकी आयोनाइजेशन कैपेसिटी बढ़ जाए. देन फर्दर इसको पास करा देंगे हम नोजल से. नोजल का काम यहाँ पे भी वही है. देन नोजल इज एक्सेलरेट द वेलोसिटी ऑफ द ionized gas and then passes through the MHD generator. MHD generator is the same work as a previous principle. There is a two electrode, and the electrode between two electrodes we pass ionized gas, and already a magnet is provided for the creating a magnetic field. When ionized gas interact with the magnetic field, there is a generate electrical field, and electric field create potential difference, and the potential difference is cause of production of electricity. Then that electricity is further supplied into converted into AC supply with the help of inverter. But the remaining part, which the remaining part of the ionized gas, which is useless, in we can say useless. So why that are useless? Again, the funda is the same. Okay, when we use the ionized gas at high temperature, then some part 25 to 30% of the ionized gas heat is extracted or converted into electricity, but the remaining parts are already absorbed by the ionized gas, and the temperature of the ionized gas reduced. So that is not efficiently work for ionizing process and to produce electricity. So that ionized gas we use for utilize in some other one. For example, we can pass through turbine and compressor and utilize the some other use in rotary work, rotation of a shaft and transform into other mechanical work. We can use as a preheater. You see this foam passing from this compressor and आर्गन से पास ये शेडिंग करके यहाँ से फिर से हम हीट एक्सचेंजर में लाते हैं, फिर यहाँ से हम इसको यूज़ कर लेते हैं. सो दिस इज अ क्लोज MHD साइकिल. फर्दर द एडवांटेज ऑफ cycle is that the maximum efficiency will be maximum up to 50 to 60% in compared to other renewable energy sources. The efficiency of this MHD cycle will be maximum, and mostly it is used where there is a power plant of the cycle. So initial setup cost will be less if already a power plant is available. It has the ability to reach full power level almost directly. You can see the maximum up to 50 to 60%. So it's a full up to power level. You can assume that it's a most बहुत ज़्यादा ही है. It is a there is a no use of mechanical parts. Up in initiation to conversion into electricity, there is a no use of turbine या other rotary parts. So there is a no noise. MHD has a very high efficiency, which has a higher than the most of the other conventional और नॉन कन्वेंशनल मेथड ऑफ जनरेशन. इस चीज़ को हम अभी थोड़ी देर पहले डिस्कस कर रहे थे कि ये अदर किसी भी रिन्यूएबल एनर्जी के कंपैरिजन में इसकी एफिशिएंसी बहुत ज़्यादा है. ठीक है. नाउ कम टू द डिसएडवांटेज. इट रिक्वायर वेरी हाई टेम्परेचर फॉर आयोनाइजिंग द गैस. एज वी नो, किसी भी गैस को आयोनाइज करने के लिए बहुत ज़्यादा टेम्परेचर की रिक्वायरमेंट पड़ती है, और यहाँ पे हमें 2500 केल्विन की तक को अब हमें यहाँ पे ऑर्गेनाइज करना पड़ा है. सो रिक्वायर्ड वेरी हाई टेम्परेचर, सो रिक्वायर्ड वेरी हाई हीट एनर्जी रिसोर्सेज. Second thing is that continuous required for maintaining the cooling the electrodes को हमें continuous cooling भी करना पड़ता है, otherwise that deform the shape या deform या thermal due to thermal stress they can damage. It require more power to maintain the magnetic field create करने के लिए वहाँ पे हमें बहुत ज़्यादा power की requirement नहीं करती. So in simple word we can say that the main disadvantage is that required more power and to produce heat, required power to cooling the electrodes, so it consume more power as compared to other. This is a main disadvantage. This all over the references of this PPT sources. Thank you so much for listening patiently.